Simple interest. Simple interest has a really simple calculation. Simple interest is the most basic way that we could calculate interest that is owed. And we're going to learn about another, actually more common way that interest is accumulated, but we're going to start with simple interest so that we can understand the basics first. So interest is calculated based on the amount that gets borrowed or invested, which we called the principal in the last video, the interest rate, and on the time. And the equation for the interest is I equals P times R times T, or I equals PRT. I stands for the interest, P stands for the principal, R stands for the rate, and T stands for the time. So simple interest adds up based on how often interest is charged. For example, you might be charged 5% interest per year, or you might be charged per month. So if R is in percent per year, then T, the time, must be in years. So if you're charged 10% interest, or 10% per year, then you need to make sure that the time that you plug into the formula is a number of years. But if R is in percent per day, like say you have to pay 1% of the loan per day, then T must be in days. So it's important to know that relationship between these time variables, or between the time scales. So 1 year is equal to 12 months, which is equal to 365 days. That's what we're going to use in this course. Some people will use 365.25 days because that accounts for leap years. But if you use 365 days in this course, that's good enough for our calculations. So here's a quick example. Sue borrows $2,000 at 5% annual simple interest, so that's per year. So that's 5% per year from her bank. How much does she owe after 5 years? Well, let's identify the variables we're given. She borrows $2,000, which means P is equal to $2,000 at 5% annual simple interest. So that means that R is equal to 5%, but we want to write percents in decimals. Whenever we do calculations with percents, we have to make sure that we write them as decimals. So 5% as a decimal is 0.05. And then finally, the time, T, is equal to 5 for 5 years. And the rate is percent per year, 5% per year, so the time should be in years. Then we can go ahead and put those values into our formula for interest. So P is 2,000, R 0.05, and T is 5 years. And we go ahead and we plug all of those values in and calculate the interest. So Sue would owe $500. So you notice that I didn't put in dollars or percent per year or years. I didn't put any units into my calculations in those intermediate steps. Here, for example, I didn't put any units in there, but I do really think it's important to put units in when you calculate, when you're writing a final answer. So in my final answer of the calculation, I put in $500 so that it's clear what I'm talking about, what this value represents. So make sure you're doing that in your final answers, you're getting those units back in there. So the interest is equal to $500. But when we're looking at this question, how much does she owe? Well, Sue owes the $2,000 she borrowed plus interest. So she owes $2,000 plus $500 is $2,500 at the end of the 5-year period. Lots of people take out loans for large furniture or appliance payments. So for example, if you buy a refrigerator for $2,000 from the Bay, but you can't afford to pay for the refrigerator, so you get a loan from the store. You agree to pay $2,000 plus simple interest for 1.5 years at a rate of 8% per month. Let's figure out how much you owe. So the interest is PRT. So the principal is $2,000. That's the amount borrowed. The rate is 8% per month. So that's 0.08 per month, which means that we need to have our time in months. So T right now, we know it as 1.5 years. We need to convert that into months. Now, if you're comfortable with how many months are in a year, we could do this very quickly, and many people will know that 1.5 years is the same as 18 months. But we can also do this with a calculation just by doing unit conversions. So if we have 1.5 years and we want to turn it into months, we say, well, there's 12 months in 1 year. So we multiply by 12 months per 1 year so that the years units cancel and we're left with just the months units. So 1.5 times 12 is 18 months. And now our rate, which is in per month, 0.08, and our time, which would be 18 months, would match up. And so we could calculate the interest that would be owed. And so we multiply those three values together, and I get that the interest owed would be $2,880. So the interest alone would be more than the value of the fridge. This isn't a very realistic loan, but I want to just give you an indication of how quickly it can add up. 8% per month would be a ridiculously high rate, so you wouldn't really see that in real life. And if after 1.5 years you had to pay back the total, you might have to pay back $2,000 plus $2,880. So after 1.5 years, the total you'd pay back in this scenario would be $4,880, more than twice the actual cost of the fridge. I wanted to show you a graphical representation of what interest looks like. So, for example, let's say you invest $1,000, earning simple interest of 5% per year for 10 years. What I want you to see is how much interest you accumulate per year. So let's say we just did a quick calculation, I equals PRT for 1 year. So $1,000 times the rate is 0.05 times 1 year. Well, that would give us a total of $50 for 1 year. So each year, so here we can see on the x-axis, we go from 0 to 1 years. The interest rises $50. And after 2 years, it's risen another $50, bringing us to a total of $100. And what you can see is that each year, as we add $50 again and again and again, we are creating a linear graph, or what we can say is simple interest is linear. You earn the same amount every year for 10 years. And this is going to be different than the next type of interest we talk about, which will be called compound interest, but we're not there yet. But I want to just give you an indication of what the growing money looks like. And I want to give you another view of that as well. So keep in mind that this first graph, this on the left here, this is the graph we were just looking at. This starts at $0 because the interest that you've earned at 0 time is $0. And so it goes up from $0 slowly. But if we look at the value of the investment, So in the second graph, this would be principal, the y-axis is equal to principal plus the interest. Then at the very beginning, at 0 years, we have a $1,000 beginning investment. And it goes up $50 per year, the same amount for 10 years. So what we were looking at before was just the rising part of the graph. Here is where the investment began, and here's the total interest accumulated after 10 years. But it also helps to see what the graph for the amount that your investment is worth as well. And you see the slope looks less significant, and that's because the y values are different to show the $1,000 beginning investment.